Hello student, I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss anomalous behavior of beryllium. Last class I have discussed the general characteristics of compounds of the alkaline earth metals. As for example, oxides and hydroxides, salts of oxoacid, that is the carbonate, sulfate, nitrate, and also I have discussed chemical properties of alkaline earth metals. Now I am going to discuss anomalous behavior of beryllium. Beryllium, the first member of the group 2 metals, shows anomalous behavior as compared to magnesium and rest of members. Further, it shows a diagonal relationship to aluminum. Okay. Now I am telling you that about this thing, anomalous behavior of beryllium. Beryllium, first point, beryllium has exceptionally a small atomic and ionic sizes and thus does not compare well with other members of the group. Beryllium has exceptionally a small atomic and ionic sizes and thus does not compare well with other members of the group. Because of high ionization enthalpy and a small size, it forms compounds which are largely covalent and get easily hydrolyzed. Second, beryllium does not exhibit coordination number more than 4 as in its valence shell. There are only 4 orbitals. The remaining members of the group can have a coordination number of 6 by making use of d orbitals. Third, the oxides and hydroxides of beryllium, unlike hydroxides of other elements in the groups, are amphoteric in nature. This is again important points. All 3 points are important. Third point, again I am telling you, the oxides and hydroxides of beryllium, unlike the hydroxides of other elements, unlike the hydroxides of other elements in the group, are amphoteric in nature. Means beryllium is amphoteric nature. It has acid as well as basic character. Now I am going to discuss diagonal relationship between beryllium and aluminum. The ionic radius of beryllium ion Be2+ is estimated to be 31 picometer. Its ionic radius is 31 picometer, and ionic potential means charge by radius ratio is called ionic potential. The charge by radius ratio is nearly the same as that of aluminum. Okay, beryllium and aluminum both charge radius ratio is nearly the same that of aluminum. Beryllium and aluminum both have same ionic potential, that is the charge radius ratio. Hence beryllium resembles aluminum in some ways. Some of the similarities are, first I am telling you, first similarities, like aluminum, beryllium is not readily attacked by acids because of the presence of an oxide film on the surface of metal. Okay, like aluminum, beryllium is not readily attacked by acid. Why? Because of presence of an oxide film on the surface of the metal. Second, beryllium hydroxide dissolves in excess of alkali. Beryllium hydroxide dissolves in excess of alkali to give a berylate ion, that is the BeOH whole 4. BeOH whole 4 2 minus, just as aluminum hydroxide gives a aluminate ion, AlOH whole 4 1 minus. Aluminum forms AlOH whole 4 1 minus, and beryllium forms berylate ion, that is the BeOH whole 4 2 minus. Next point, third point, the chloride of both beryllium and aluminum have chloride bridged chloride structure. The chlorides of both beryllium and aluminum, okay, both chlorides of beryllium means beryllium chloride and aluminum chloride, both have chloride bridged chloride structure in vapor phase. Both the chlorides are soluble in organic solvents, means beryllium chloride and aluminum chloride, both the chlorides are soluble in organic solvents, okay, and are a strong Lewis acid. They are used as Friedel-Crafts catalyst. Okay. Now next point is, that is the fourth point, beryllium and aluminum ions have a strong tendency to form complexes like BeF4 2 minus. Beryllium forms BeF4 2 minus, and aluminum forms AlF4 3 minus. Okay, beryllium forms complex BeF4 2 minus. Okay, and aluminum forms aluminum F6 3 minus, aluminum F6 3 minus. Both are complex. These I told about the diagonal relationship of beryllium and aluminum. Now I am going to discuss some important compounds of calcium. This is very, very important. Important compounds of calcium are calcium oxide, calcium hydroxide, calcium sulfate, calcium carbonate, and cement. These are industrially important compounds. The large scale preparation of these compounds and their uses are now I am telling you. First, calcium oxide. Calcium oxide, also called quicklime, quicklime, Q-U-I-C-K, quicklime, L-I-M-E, that is a calcium oxide. It is prepared on a commercial scale by heating limestone, means calcium carbonate, in a rotary kiln at 1070 to 1270 Kelvin. It means at high temperature. Temperature should be roughly between 1070 to 1270 Kelvin. Then calcium carbonate will break into two, calcium oxide and CO2. Means calcium carbonate, on heating it gives CaO plus CO2. The carbon dioxide is removed as soon as it is produced to enable the reaction to proceed to completion. Quickly carbon dioxide is removed. Calcium oxide is a white amorphous solid. One is a crystalline, other type is amorphous powdered form. Then calcium oxide is a white powdered form solid, that is called amorphous solid. It has a melting point of 2870 Kelvin, very high, 2870 Kelvin, 2870 Kelvin melting point is very high. On exposure to atmosphere, it absorbs moisture and carbon dioxide. Both it will absorb. Calcium oxide in atmosphere, it absorbs moisture as well as carbon dioxide and forms calcium oxide. When it absorbs moisture, means H2O, then calcium oxide plus H2O, it forms calcium hydroxide, and calcium oxide plus CO2, it forms calcium carbonate. The addition of a limited amount of water breaks the lump of lime. This process is called slaking of lime. Question is asked. The addition of limited amount of water breaks the lump of lime. This process is called slaking of lime. Quicklime slaked with soda gives solid soda lime. This question is also asked, important question. Quicklime slaked with soda and gives solid soda lime. Being a basic oxide, it combines with acidic oxide. Calcium oxide is a basic oxide. Then being a basic oxide, it combines with acidic oxide at high temperature. Means calcium oxide plus silicon oxide. Silicon oxide is a acidic oxide. Calcium oxide is a basic oxide. Then CaO plus SiO2, it gives CaSiO3, calcium silicate. And other reaction, that 6CaO plus P4O10 means P2O5, dimer of P2O5, that is P4O10. This is also acidic oxide. P4O10 is acidic oxide. It reacts with basic oxide, means calcium oxide. And balanced equation I am telling you, 6CaO plus P4O10, it is giving calcium phosphate, Ca3PO4 whole 2. Tooth, our tooth is made from calcium phosphate. Bone generally will be calcium phosphate, very strong, Ca3PO4 whole 2. Then now this balanced equation, it becomes 6CaO plus P4O10, it gives 2Ca3PO4 whole 2, calcium phosphate. What is its application, uses? Then now I am telling you. It is an important primary material for manufacturing cement. In cement, main constituent is calcium oxide. I will discuss in details for cement. Okay. Now, first application I am telling you, it is a constituent, important constituent of cement, and is the cheapest form of alkali. Second use, it is used in the manufacture of sodium carbonate from caustic soda. It is also used in the manufacture of sodium carbonate from caustic soda, that is the NaOH. Third, it is employed in the purification of sugar. If you want to purify sugar, that time it is used. It is employed in the purification of sugar and in the manufacture of dye stuff, means color dye stuffs. I have told you about the first compound. I told you about calcium oxide. Now I am going to discuss second important compound, that is the calcium hydroxide, calcium hydroxide, also called select lime. Question is asked. CaOH whole 2, calcium hydroxide is called select lime. Calcium hydroxide is prepared by adding water to quicklime, means calcium oxide plus H2O. Okay, it is a white amorphous powder. This is also powder form, amorphous. Calcium hydroxide is a white amorphous powder. It is sparingly soluble in water, very less soluble. The aqueous solution means if calcium hydroxide, if you will dissolve in water, then it is called aqueous solution. Okay, the aqueous solution is known as lime water. This is also important question. What is the lime water? Then the aqueous solution of calcium hydroxide is called lime water. Calcium hydroxide is known as select lime. And suspension, again important question. And a suspension of select lime in water is known as milk of lime. Okay, these all terms, small terms are important for examination. Again I am telling you, the aqueous solution is known as lime water. Okay, first important things. And a suspension of select lime means calcium hydroxide in water is known as milk of lime. Okay, suspension is called milk of lime. When carbon dioxide is passed through lime water means calcium hydroxide solution plus CO2, it forms calcium carbonate plus H2O. On passing, if you will pass more carbon dioxide, then what will happen? On passing excess of carbon dioxide, the precipitate dissolves to form calcium hydrogen carbonate, means calcium bicarbonate. Actually, it is if calcium hydroxide plus CO2, it is forming calcium carbonate plus H2O. If you will pass more carbon dioxide, then on passing excess carbon dioxide, the precipitate dissolves to form calcium hydrogen carbonate, means calcium bicarbonate. Okay, calcium carbonate plus CO2 plus H2O, it is forming CaHCO3 whole 2, calcium bicarbonate, CaHCO3 whole 2. Milk of lime reacts with chlorine. Again, very important reaction, important for examination, any type of examination. Milk of lime reacts with chlorine to form hypochlorite, means it gives hypochlorite. And a constituent, what is the hypochlorite? Then hypochlorite is a constituent of bleaching powder, that is the CaOCl whole 2. CaOCl whole 2, that is the bleaching powder. Then here reaction I am telling you, this 2CaOH whole 2 plus 2Cl2, it forms CaCl2, means calcium chloride, plus CaOCl whole 2 bleaching powder plus 2H2O. It forms a 3 product. First product is calcium chloride. Second is important, CaOCl whole 2 hypochlorite, calcium hypochlorite, and third is the water. Hence balanced equation is 2CaOH whole 2 plus 2Cl2. It forms CaCl2 plus CaOCl whole 2 plus 2H2O. What is its uses? Then first use I am telling you, it is used in the preparation of mortar, 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 a building material. Second, it is used in whitewash. You have seen house whitewashing, house whitewash. There it is used. It is used in whitewash due to its disinfectant nature. Okay, this is also used as a disinfectant. Third application, third use, it is used in glass. It is used in glass making. Okay, and also in tanning industry, TANNING, tanning industry, and for the preparation of bleaching powder and purification of sugar. Okay, these are the use. I told you it is used in glass making, means in glass industry, second in tanning industry, third in the preparation of bleaching powder, and fourth purification of sugar. Then this I have told second, I can say, important compound of calcium, that is the slacked lime, calcium hydroxide. Now I am going to discuss third important compound, that is the calcium carbonate, CaCO3. Calcium carbonate occurs in nature in several forms like limestone, chalk, marble, etc. It can be prepared by passing carbon dioxide through slacked lime, means calcium hydroxide, or by addition of sodium carbonate to calcium chloride. Reaction I am telling you, calcium hydroxide plus CO2, it forms a calcium carbonate plus H2O. In this way you are getting calcium carbonate, CaOH2 plus CO2. It gives CaCO3 plus H2O. Now you are getting calcium carbonate. Second, calcium chloride plus sodium carbonate, Na2CO3. It forms a calcium carbonate plus 2NaCl, sodium chloride. Here also you are getting calcium carbonate. Excess of carbon dioxide should be avoided. In this reaction you are passing carbon dioxide, then excess of carbon dioxide should be avoided. Why? Since this leads to the formation of water soluble calcium bicarbonate. That's why excess carbon dioxide should not be used. I told you calcium hydroxide plus CO2, it is giving calcium carbonate, but excess carbon dioxide means it will form calcium hydrogen carbonate, which is water soluble. Okay. Calcium carbonate is again a white fluffy powder. This is also powder, you might have seen. It is almost insoluble in water. In water it is almost insoluble, it will not dissolve. Calcium carbonate is almost insoluble in water, but when heated to 1200 Kelvin, if you will heat at 1200 Kelvin, it decomposes to evolve carbon dioxide. Means if you will heat a strong heating at 1200 Kelvin, it breaks into calcium oxide plus carbon dioxide. Means CaCO3 at 1200 Kelvin, it will give calcium oxide plus CO2. It reacts with dilute acid to liberate carbon dioxide. Calcium carbonate, it reacts with HCl, calcium carbonate plus 2HCl. It forms calcium chloride plus H2O plus CO2. Okay, and with H2SO4 also it reacts. Calcium carbonate plus H2SO4, it forms calcium sulfate plus CO2 plus H2O. Okay, these are the reaction I have told you, important reaction of calcium carbonate. What is its use? Then I am telling its use. It is very, very important use. It is used as a building material in the form of marble. Marble means calcium carbonate. It is used as a building material in the form of marble and in the manufacture of quicklime. calcium carbonate along with magnesium carbonate is used as a flux. This question is asked, what is the flux? Then mixture of calcium carbonate along with magnesium carbonate is used as a flux in the extraction of metals such as iron. Okay, and iron is going to be extracted, then mixture of both calcium carbonate and magnesium carbonate is used as a flux, FLUX. Especially precipitated calcium carbonate is extensively used when it is a fresh calcium carbonate, you can tell. Especially precipitated means fresh. Precipitated calcium carbonate is extensively used in the manufacture of high quality paper. It is also used as an antacid in medicine. Okay. And next use, mild abrasive. It is used as a mild abrasive in toothpaste, a constituent of, and also gum, chewing gum, in that it is also used, a constituent of chewing gum, and a filler in cosmetics. In cosmetics, it is also used as a filler. Now I have discussed about the calcium carbonate. Now next compound I am going to tell you, that is the calcium sulfate. Very important compound, calcium sulfate, also called plaster of Paris, POP, plaster of Paris, and its formula is calcium sulfate half H2O. You should not confuse with gypsum. There are two compounds in the same name, calcium sulfate. Then with calcium sulfate, if one half H2O is attached, CaSO4 half H2O, then it is called plaster of Paris. And when two molecules of water is attached, means CaSO4 2H2O, then it is called gypsum. Both questions are asked. Now what I have discussed, only from these many questions are asked in examination. Then now I am telling more about the calcium sulfate, that is the plaster of Paris, CaSO4 half H2O. It is a hemihydrate, hemi means half H2O, hemihydrate of calcium sulfate. It is obtained when gypsum, actually you will obtain the plaster of Paris from gypsum, that is the CaSO4 2H2O. When you will heat gypsum, means CaSO4 2H2O, when you will heat at 393 Kelvin, then this CaSO4 2H2O, it will break and it will form CaSO4 half H2O. Balanced equation I am telling you, 2 CaSO4 2H2O, 2 moles of CaSO4 2H2O, it gives 2 moles of gypsum, 2 moles of plaster of Paris, 2 moles of 2 CaSO4 H2O. Here 2 CaSO4 H2O, then you are getting it from the 2 CaSO4 2H2O. From 2 CaSO4 2H2O, you are getting 2 CaSO4 1H2O. Then if you will use 1 CaSO4 2H2O, then you will get CaSO4 half H2O. Okay, but balance equation I am telling you, 2 CaSO4 2H2O water is attached, it gives 2 moles of calcium sulfate, 1 H2O water is attached, okay, plus 3 H2O, means 2 moles are giving 1 H2O, then 1 mole will give half H2O, correct? But balance equation is like that, 2 CaSO4 2H2O, it is attached, it gives 2 moles of CaSO4 and 1 H2O water is attached. Correct? Plus 3 H2O. If we will heat above 393 Kelvin, then what will happen? Then now in this you have seen half H2O water is attached. But if you will heat this gypsum, from the gypsums you are getting CSO4 half H2O, or if you want to make it 1, then you 2 CSO4 1 H2O you can tell. Anyway, CSO4 half H2O, 1 CSO4 half H2O. If you want to tell, you will tell 2 CSO4, then it will become 1 H2O. CSO4 half H2O, 1 CSO4, then half H2O. If 2 CSO4 is there, then 1 H2O. Anyway, you can tell. Then I am telling you, if you will heat above 393 Kelvin this gypsum, then that half H2O water will also go outside. It will become anhydrous calcium sulfate. Then above 393 Kelvin, no water of crystallization is left, and anhydrous calcium sulfate, that is CaSO4, is formed, and this is known as dead burnt plaster. Dead burnt plaster question is asked. Okay, these compounds are very, very important. Many questions are asked, multiple choice question. Okay. Now I am telling you further, it has a remarkable property of setting with water. This plaster of Paris, POP, it has a remarkable property, very important property of setting with water. Means if you will put water, it will absorb. On mixing with an adequate quantity of water, it forms a plastic mass that gets into a hard solid. After absorbing water, it will become hard in just very fast, in 5 to 15 minutes. In 5 to 15 minutes, it become hard after getting water. Okay. Now it's a huge, you can see, huge of plaster of Paris. The largest use of plaster of Paris is in the building industry, as well as plasters. It is used for immobilizing, immobilizing the affected part of organ where there is a bone fracture or a sprain. There it is used. Again, you just listen. It is used as it is used for immobilizing, means it should not move. Immobilizing the affected part of organ where there is a bone fracture or a sprain. You have seen that person got the plaster, that plaster only on in hand or leg. It is also employed in dentistry. Dentistry means dental problem, tooth problem. There also it is used, employed in dentistry, and also it is used in ornamental work, and for making cast of a statue and busts. A statue we have seen that is made from the plaster of Paris. Many statue we have seen white color, that is made up of plaster of Paris, POP. Okay. Now I am telling about the cement. Cement, very, very important material. Cement is an important building material. It was first introduced in England in 1824 by Joseph Aspdin. It is also called Portland cement because it resembles with the natural limestone quartered in the Isle, Isle of Portland in England. Okay, that's why it is called Portland cement, because it resembles with the natural limestone limestone quarried in the Isle of Portland. It is England. Cement is a product of, now listen very carefully, cement is a product obtained by combining of material rich in lime means calcium oxide, with other material such as clay. Means two major things, CaO plus clay, but clay contains 4-5 things. Clay contains, first it contains silica means SiO2. Second, oxides of aluminum. Third, oxides of iron. Fourth, oxides of magnesium. Means this clay contains 4 material. First, silicon oxide. Second, aluminum oxide. Third, iron oxide. Fourth, magnesium oxide. Okay, but actually these are called clay. Then CaO plus clay, that is the cement. But under the clay, these 4 will come: mixture of silicon oxide, aluminum oxide, iron oxide, and magnesium oxide. 4. The average composition of Portland cement, I am telling you, question is asked. Then calcium oxide will be around 50 to 60% main constituent, and silicon oxide 20 to 25%. Okay. Third, aluminum oxide Al2O3 5 to 10%. Magnesium oxide 2 to 3%. 2 to 3% magnesium oxide, and iron, that is the Fe2O3, that is the ferrous oxide, less 1 to 2%, and also SO3 will be there. SO3, sulfide, sulfur trioxide gas, you can tell. SO3, it is also same like Fe2O3, 1 to 2%. For a good quality cement, the ratio of silica means SiO2 to alumina means Al2O3, this ratio SiO2 and Al2O3 ratio should be between 2.5 to 4. 2.5 to 4. In this ratio it should be there for a good quality of cement. Always silicon oxide aluminum oxide ratio should be between, you can say, 2.5 and 4. And the ratio of lime to the total of the oxides of silicon, that also you have to think, ratio of lime to silicon oxide. Okay, the ratio of lime to total of the oxide, you will consider silicon oxide, aluminum oxide, iron oxide, all oxide if will compare, if will add, then total oxide, that is called total oxide. Silicon oxide plus aluminum oxide plus iron oxide, this is called total oxide. In that magnesium oxide also you can add. Then what is the ratio of calcium oxide and these oxides? Should be close to 2, called close to 2. Okay, 1:2 ratio. Okay, that is overall you can tell that this ratio of calcium oxide and these oxides, silicon oxide, aluminum oxide, iron oxide, that be 2, ratio should be 2. Okay, then it is called good quality of cement. The raw materials for the manufacture of cement are, how will you prepare the cement? Raw material, then limestone and clay. These are the 2, you can say, raw materials, limestone and clay. And already told you clay contains 4 oxides. When clay and lime are strongly heated, how will you make cement? I am telling you, when clay and lime lime are strongly heated together, they fuse and react to form cement clinker. CLINKER, cement clinker. After heating these two, limestone and clay, then what you will get, that is called cement clinker. This clinker is mixed with 2 to 3% by weight of gypsum, means calcium sulfate twice H2O. Then cement will be formed. After heating you will get clinker, and a clinker by weight you will mix 2 to 3% by weight. Gypsum we have to mix, calcium sulfate 2H2O. Then cement will be formed. Thus important ingredient present in Portland cements are, now in the term of I am telling you this things, calcium. In term of calcium, after making this here important I am telling you about the important ingredient present in Portland cements are, first, dicalcium silicate. Dicalcium silicate means Ca2SiO4 26%. Dicalcium silicate 26%. Tricalcium silicate, that is a Ca3SiO4 SiO5. Okay, tri means Ca3SiO5. Okay, dicalcium silicate means 4 SiO4 Ca2SiO4, and that is a 26%, and tricalcium silicate Ca3SiO5, it is a 51%, and tricalcium aluminate, that is a Ca3Al2O6, that is the 11%. Then main constituent, in shortcut you can tell, dicalcium silicate 26%, means Ca2SiO4 26%. Second, tricalcium silicate Ca3SiO5 51%, and third, tricalcium aluminate, that is the Ca3Al2O6 11%. Okay, this is the important in a shortcut way you can tell in the term of silicate. Okay, now setting of cement. Setting of a cement. What is the setting of cement? You are knowing, you have seen also during construction of house, floor setting or roof setting. That time you might have seen that setting, that is called setting of cement. 21 days you are putting under water. After flooring and roof, then now you are keeping under water for 21 days. Okay, then that is actually setting of cement. Now I am telling you details. When mixed with water, the setting of cement takes place to give a hard mass. This is due to the hydration of the molecules of the constituent and their rearrangement. Means you have seen in a cement many you can say things are present, many materials are present. Then they will absorb water, and when they will absorb water, then that time they will release heat. Then just to because when it will go released, then heat will be released, then cement will be dry. Mixture of cement, sand, concrete, what you have mixed, that will come dry. Then it can crack can take place, means floor can crack if you will not put the water. Because in the beginning when you have mixed cement, sand, concrete, and water all you have mixed, and you have done the plastered like that, or this flooring you have done, then that time, because already little water is there, then that water will be absorbed. That water reaction, chemical reaction will start, and they require water. All constituents, they want water. Then when they will absorb water, then it will release heat. That is called hydration. Release of heat is called hydration, because they are absorbing water, that time they are releasing heat. Then that is called hydration energy. That's why it requires more water. Then after 24 hours, you are putting complete under the complete water for 21 days, so that there should be no crack. Otherwise, some carbon dioxide gas will also come out, and heat will also come out. Then floor will crack if you will not put under the water. Means sufficient water, too much water is required. That is called actually setting of cement. Then this I told you, when mixed with water, the setting of cement takes place to give a hard mass. This is due to the hydration of the molecules of constituents and their rearrangement. The purpose of adding gypsum is only to slow down the process of setting of the cement. Otherwise, it will set very fast and crack will be there. That's why gypsum is mixed. Gypsum only, what is the reason, can be asked in examination. Then gypsum is mixed. The purpose of adding gypsum is only to slow down the process of setting of cement, so that it gets sufficiently hardened. Okay. Now application, you can see. Application. Usage. Cement has become a commodity of national necessity for any country, next to iron and steel. First is iron and steel, and then second is the cement. Okay. It is used in the concrete and reinforced concrete. After that, it is used in plastering also, and in construction of bridge, dams and buildings. Already you know. Now I have discussed all compounds of, or you can say important compounds of calcium. Okay, I have told you, because all are the very, very important products. That is the important compounds of calcium. Now I am telling you last biological importance of magnesium and calcium in our body. This is also required. Okay, that also I am telling you. An adult body means any person, normal person, an adult body contains about 25 gram magnesium. Keep in mind, 25 gram. Adult body means you can consider 60-65 kg person, and that contains 25 gram of magnesium, and 1200 gram of calcium, means 1.2 kg. 1.2 kg, 1200 gram roughly calcium, compared with 5 gram of iron. Only iron is a 5 gram in our body, and copper is very less, 0.06 gram of copper. The daily requirement of the calcium and magnesium I am talking about, the daily requirement in the human body has been estimated to be 200 to 300 milligram. Between 200 to 300 milligram calcium we require. Okay, roughly both calcium and magnesium between 200 to 300 milligram is required. Okay, all enzymes in our body, many enzymes will be there. Enzyme is biological catalyst. All enzymes that utilize ATP, powerhouse energy in our body. All enzymes that utilize ATP in phosphate transfer requires magnesium. Role of magnesium, you can see. During phosphate transfer requires magnesium as the cofactor. The main pigment of absorption of light in plants is chlorophyll. Plants absorb light. Then without chlorophyll it is not possible, and in that chlorophyll magnesium will be there. Magnesium actually absorbs. In chlorophyll magnesium is present, that absorbs actually light. Okay, and green, plants looks green due to the presence of chlorophyll. Question is asked. Okay, about 99% of body calcium is present in the bone and teeth. See, whatever calcium is present in our body, 99% of calcium is in the form of bones and teeth. It also plays important role in a neuromuscular function. Okay, nerves now. Neuromuscular, muscle also, in that it is there. In muscle also magnesium will be there. Then it's an important role in neuromuscular function, and also you can tell interneuronal transmission. In cell membrane also it is required. Cell membrane integrity and blood coagulation. In blood also it is required. It is present, blood coagulation. The calcium concentration in plasma, in blood I am talking about. The calcium concentration in plasma is regulated at about 100 milligram per liter. In our blood it will be 100 milligram per liter, and it will regulate in the entire body. It is maintained by two hormones. What are the two hormones? Then calcitonin is the first hormones, and second is parathyroid. Thyroid, you have seen neck, near the neck, this one disease is there, that is called thyroid problem. Then there parathyroid one, this will be their hormones. Then this calcium is maintained by these two hormones. First hormones calcitonin, and second is parathyroid. And one more important things I am telling you. Daily we require, our bone, they will replace calcium, and daily require 4 milligram per day. Okay, it is not like that bone, what is there, it is fixed. It will dissolve, it will exchange. Do you actually you might be not knowing, but I am telling you that bone is not an inert. And unchanging substance. It is not inert, it is active and also changes, but it is continuously being solubilized, means it can dissolve and again it can absorb, and redeposited means always it will be depositing, and redeposited to the extent of 400 milligram per day in man. Okay, that's why we should eat more calcium, magnesium, iron, copper. You see, they are the important things for our body. Other things are also important, but this here related to this second group metal I am talking about, calcium, magnesium are very, very important in our body. All this calcium passes through the plasma. Now I have finished complete group 2 elements completely 100%. Okay, next class I will discuss new chapter. I will start P block elements. Now I am stopping here. Thank you.